Hola, buenos dias. It's a great honor for me to be here, and specifically as I am a nutritionist by training, and I think talking to an audience of probably mainly food technologists is a true honor. Any nutritionists besides me in the room? Oh yeah, great, there's somebody, fantastic. Great to see you here. Okay, so I think I would like to bring together, as I said, this is for me something that is honestly important. If we want to address food system challenges, I think we need to think interdisciplinary and bringing the knowledge from one discipline also across the other to actually be successful and translate. And I think also from all the beautiful research we have seen, my talk will also focus more on how we truly translate and see an impact on the food scale. So let me start by, when we're talking about a balanced diet, it has different dimensions. And the very first one is actually to achieve adequacy. Adequacy at a level of the nutrients, so macronutrients, the micronutrients, etc. Then we have also, our diet needs to have completeness, so it needs to bring all the sources of the nutrients that we need. Diversity, so a varied diet is something that helps you also to really meet the recommendations that are outlined often at a country level as well. And then also for certain of the things, it's moderation. So moderation, obviously, when it comes to the beautiful things that my presenter was sharing on the biscuit side, so I think we need to also moderate intake of some of the products that we like and then choose also the ones that are bringing to the diversity. But what I want to really focus on to enter in two more specific examples is on the adequacy, considering micronutrients and macronutrients. And I will start with the micronutrients first, because this remains, micronutrient deficiencies remain still a problem around the world in different levels and prevalences of nutrients. And I think key concerns remain really with iron deficiency anemia. We still see a lot of vitamin A deficiencies, zinc deficiencies. I added here iodine because that is a very great example to show success of fortification and also the intersection between feasibility of fortification at the same time as regulation acting upon the data and making, for example, and you have that since many years in Chile, the salt fortification mandatory. All the countries that are having mandatory salt fortification could really almost eradicate iodine deficiency. And I'm coming from a part of the world where, unfortunately, we are not looking as good. As a nutritionist, I'm getting really concerned because people choose now trend-based sea salt, etc., and sea salt often is not iodized, and it's not mandatory neither in Switzerland nor in Germany, which is the other country that I originate from. And both we see, honestly, an increase in the prevalence of iodine deficiency. So we must pay attention, and I think we can acknowledge that fortification is a quite effective tool to address some of these things. So you may see that certain areas probably are not as bad, and you say, okay, why bother? I mean, is it really something we still need to talk about? Nutritionists have been talking about that for decades. Maybe we have had enough success. I think one element I want to throw in is this very recent publication. It's a study that has been modeling the impact of climate change, increased temperature, etc., because this will dramatically impact the food supply and the production, really at agricultural level. And it influences really what eventually also would be the foods and what micronutrients they would deliver. So that can be at the same time at a level of animal foods, so cattle, milk, etc., but also crops and grains. And as you can see, the risk for having actually a decrease in terms of micronutrients coming from food supply is actually quite alarming, and I think specifically in this part of the world, the risks are relatively big to have a larger gap in the micronutrients that will come from the food. So I think we need to keep these elements in mind as well when we think about fortification also moving forward. So now this slide actually is just to show as well, so how can we truly act? So as nutritionists, we obviously have the role to help people to find balanced diet where they hopefully would get most of the micronutrients they need. Unfortunately, in many parts of the world, as I showed before, that is not the case for different reasons. May it be food choices, but may it also be affordability or access to nutrient-dense foods that bring these micronutrients, and consequently, we have different options. So it can be in very specific situations where there is a big gap. So for example, very severe malnutrition of a child, you would go with a supplementation, which is medically observed, and then also for a limited period of time. This can also be, supplementation can also help during specific periods of life, like during a pregnancy, where it will be otherwise difficult to obtain some of the most relevant micronutrients. But then I think what I want to focus on is the food fortification. Food fortification has been a public health strategy for many decades, which helps really to address the deficiencies, but in a way that it is considering the foods which are regularly and widely consumed for fortification, to be sure to really have a large reach and a scale to reach people, and also, if possible, at all socioeconomic levels. So here, in the bottom, I put some examples. So we have large-scale food fortification programs, which are mandated by governments, and in Chile you have several, I think, quite successful ones of them. So the salt iodization is a very successful program. Then you can also see fortification of sugar, like in Central America, where I have spent time. Vitamin A in sugar has been a very long-term successful story to also reduce blindness in children. Then you have flour fortification, which is very familiar here in Chile for you. However, is it always consumed? We see globally for flour fortification, in terms of how much it covers really the needs, it's a bit mixed data. Huh? And then you have oil fortification as well. So as an industry, or as a food manufacturer, we can also fortify foods which we know could reach also some of the people in need. That could be something like a seasoning, like a bouillon cube, where in certain parts of the world we know that has a penetration of 95 to 98% of households that really on a daily basis consume that. And knowing that data fact triggered us to actually consider, can we then also fortify that to bring that additional benefit when people use this for cooking their local dishes. That is, I think, something which is quite interesting. Another opportunity is obviously when you have, you can also use that for more targeted populations with also specific micronutrients. If you have a child, a growing child has a higher need for certain micronutrients than an adult. And therefore, a targeted product that is addressing the needs of the child at a certain age can be a solution as well. So what do we need to pay attention to? I think one thing is very important to understand the local situation. What is actually the main gaps in the nutrient requirements or over deficiency? Here again, it shows again that iodine, where we have the fortification programs successfully implemented, you don't see really that there are gaps. But for the other nutrients, depending on the country, they can be very different. So I think, so for us as well, we look at the country available data. That is often a challenge as well to what quality data is available, but whatever we use to the best to the knowledge, and actually then address the needs accordingly. And what is also important is on the second side, as I said, there can be differences, and here is an example of iron, where the needs change over time and where a targeting toward that age group or that situation may make sense. So now we have food technologists. So I asked my dear colleagues in the organization to share a few of their slides with me that I would like to show as well. So what are technical solutions? And I'm focusing now here very specifically on iron. So the challenge is when you fortify, and specifically with something like iron, that it can have quite a strong impact on the sensory things. So we have heard that sensory is important, and probably what we haven't spoken, or that what Rick didn't speak about a lot, was actually also the visual appearance. So if you have a dish that has a certain color, you would expect that color when you use your regular ingredients. If suddenly that color turns very dark in a stew because you're using an iron-fortified bouillon cube, it may surprise you, and that may also then decrease a bit the acceptability. So there is all the sensory aspects that we need to address and need to find a good place so that we achieve that consumer acceptance, because I think it is very obvious that a food is only contributing to something if it truly enters your mouth and your digestive system. If you only see it on shelf but leave it there, it will not impact, obviously, your own situation. What is interesting, I think, is also to understand that from a technical perspective, this fortification influences the sensory aspects altogether in the same way, unfortunately. So it's not only the, it's actually the taste, it's the odor, and it's also the color that can be impacted. So we need to find solutions, depending on the food product that we have, to find the source that you can use to limit the impact on the sensory aspects. One thing. The other thing is also that there is actually, we obviously have products where you want to have a certain shelf stability. But if you have a stable micronutrient, it means when you ingest it, it also is relatively stable and has a lower bioavailability. So these go in opposite directions. Usually you have a higher stability in product, but then a lower bioavailability in the body. So there's another compromise to find. How can we meet now, can we find a fortificant that at the same time has this desirable or acceptable sensory aspects, but also brings a relatively good parallel between being stable in a product at the same time that it has a certain bioavailability. And here you can see on the left-hand side, that's the relative bioavailability, so that can vary quite a lot. And so depending again on what your food matrix is, you may still need to choose, for example, in the case of bouillons, a lot of companies are using the ferric pyrophosphate because it's the only one that has actually the possibility to not have that very strong impact on the sensory element. So how do we address the challenges in our how can we address that? There are different technical solutions, just pointing out here. So one is actually that we can work on the particle size, so solubilizing them. When you have smaller sizes, you know, it becomes then also better bioavailable. There is also the way that you protect the micronutrient by encapsulation, so that's only released when it actually enters the part in the body where it should be released. There are some actually also interesting organisms that have a very high intrinsic level of micronutrients, like here this Aspergillus oryzae. The problem with that is that if you take these organisms, I mean, you need to obviously know how can you standardize the content. So that challenges always with everything. And then the last one is actually what is this molecular entrapment. And I will show you one example of how we have been using this technology of entrapment for actually one of the food products and what positive impact that can have. So what did we do? We worked together with the Massey University in New Zealand, and they had worked on, we have worked on an entrapment, because this is used now in a milk matrix, in a powdered milk matrix, and we use the casein, which is part of the protein fraction. And we use that to actually build a kind of cover, or, you know, like entrap the iron in that matrix. That again helps you to be stable in product, but also it helps you to get released in the stomach. And what you can see on the right-hand side is indeed, when we tested that, it's exactly delivering and improving the challenges that I had showed you in the slide before, which, first of all, it gives you a better solubility. It's almost like iron sulfate, and that is, in the nutrition world, mostly one of the references, the golden standards in terms of iron fortificant. And then also we have really a much better sensory profile than the ferrous sulfate. So this is actually a tool that helps to overcome some of the challenges that we just have seen. So that is on the product level. So, but what does it do for humans? So we tested as well the absorption, and we could see, and this is the cell data, that basically we have also a better uptake in the cells using that entrapped iron compound. And our nutrition colleagues, they actually modeled as well, when we now use these micronutrient fortified milk, what would it bring in terms of that specific age group, which are children, in terms of meeting their micronutrient requirements. And on the right-hand side of the graph, you can see here the percentage of the nutrient inadequacy, and how, by replacing a glass of milk with one that brings additional micronutrients in, can actually reduce the level of inequality. So I think that is quite interesting to see that that is something that delivers on a lot of fronts. Okay. So changing gears now from micro to macronutrients, so going to the protein world. Proteins is something that it's, I think, quite trendy these days. Everybody talks about it. I think there's also a restart of understanding, are we truly understanding what the micronutrient requirements are. So that's why I didn't put a reference figure here, because there's a lot of discussion in the field. But overall, I think for an adult, there is an average still for 0.8 gram per kilogram body weight. But there is discussion, is that sufficient when you age, should you have more, etc. So that aside, we can see as well that a lot of countries are actually above and beyond what the requirements are. And you can see that the darker, the more you're actually on the higher side of the intake. And this is actually something where there is a large diversity of foods that can provide protein, which is not only animal-based, but also largely plants can bring some of this. But in countries that are with high intakes, and specifically more on the western side of the world, we also see that mostly it comes from animals. And there, when we want to meet now not only the nutritional requirements, but also we want to look at what's the environmental footprint. The environmental footprint of an animal-based protein is much higher than of a plant, and consequently there's room now to start shifting a bit towards, you know, like reducing slightly the animal ones and increasing the plant protein one. So that is an area where we also have very practically worked on, and different formats here. So if we would like to see how can we help people to now move from their established habits and their cultural context into an easy way to maybe also go into this transition, I think one possibility, one of many obviously, but one option is to replace some of the known animal-based foods, such as the meat, with something that is an analog that looks like the meat. So then you don't need to acquire new skills in cooking, etc. And it makes it an easier step with a lower barrier of entry if you want. Not for everyone, but I think it's a legitimate entry point for many. And so what you see here on the left-hand side is also that you need, basically, if you start from soy or pea or something, you need at the end of the day come with a fiber-like structure, as you see in the bottom. And that obviously requires also processing to get to that sensory experience that eventually will drive as well the preference. On the right-hand side, and that's the one I would like to focus on, you can also work on or replacing dairy altogether, but you can also combine. And the combination of plant with dairy gives you obviously a lower footprint already on the environmental side, but it also allows you to maintain the taste experience that you have in dairy and bring the good quality as well from the nutritional side from plant-based protein sources. Challenge is that dairy and a powder or a paste out of a soybean do not behave in the same way. So you're all food technologists, you know that better than me. Starting, however, at the beginning of sourcing, I think it's also important to pay attention to that. If we want to shift the scale, we also need obviously to understand what's available. And here on that plot, you can see that on the right-hand upper angle, these are basically soy, yellow pea, and faba beans. These are in high supply, but all the others are in relatively low supply. And the other element that is important on that slide is if you look at the left-hand side, all that list of things is what also as a food producer you need to consider when choosing a plant protein source for your product. So it's actually quite complex. And I think what is also for me always striking is that soy is at high supply, but still more than 90–95% of soy is still produced for animal feed. It's not even for human feed. So just all of that to understand where we need to start, and that also sets the scene for development of products. Then, as a nutritionist, we obviously pay attention not only how much protein, but what's the quality of the protein. And here you can see, I hope you see that still in the end, on the left-hand side, this is a measure for the digestibility of the protein, which actually is a combination of the amino acids that are in that protein. So, and if you obviously have one that is essential that you cannot build in your body yourself, and that is at a low rate, it actually can also limit the basically the value of that protein for the body altogether. So that is the limiting essential amino acids. And the other thing is also how can actually the body digest that. That is also depending a bit on the structure and on other components. And you can see I draw a small line here after the first two which are the animal-based. They are at a very high digestibility level, but if you go to the right, you can see that some of the plant-based proteins, they have very different levels. So soy has a very high one, so that is why that is a good choice to start off from, because you have a quite good protein profile as well and a high digestibility level. And interestingly, if you combine some sources, you can actually match the amino acids so that eventually you get actually a better quality protein at the end of the day. As we were talking processing, I just found that interesting from this publication as well, that they studied as well the impact of processing. So if you take a steak and you prepare it in a different way, you can actually decrease the digestibility or the availability of your amino acids. So the higher you fry or the higher you grill, you can actually decrease. So I think these are things we do, all of us, but we are probably not conscious. And some of them, these essential amino acids, are actually then bound through Maillard reaction, which obviously gives you fantastic flavor, but also kind of impacts the digestibility. And then in the bottom, this was interesting. It's a plant, it's a soybean, and I apologize for the size of that. But this one actually shows if you do a wet heating at 80 degrees, compared to the soybean protein at a raw state, you can increase already the protein digestibility from 46 to 52%. So just the wet heating at 82%. So if you go higher in temperature, and also boil for longer a period of time, you can go up in for example, with a autoclaving at 110% for 45 minutes, you raise that digestibility from 46 to 84. So it's almost double. So that, I think, is quite interesting. Then after that point, you start to see decrease again. So there is an optimum level which processing can influence. Now, coming back to our hybrids. So what is now the challenge that we face? The challenge, and I think you guys, again, know that, we have on the one hand side dairy, that is a hydrophilic liquid, and then you have actually on the other side plant cells that behave totally different and are hydrophobic. So that doesn't work well together if you want to bring that together in a soluble and homogeneous form. And what is actually the trick here that you can use? There are different ways, again. You can use enzymes. That is one way to do it, to disentangle. But also there is data showing that if you use a combination of milk and soy, a smart one, and then you adjust the pH and the temperature, it can basically result overall in improving the hydrophilic part. And that is really by avoiding these protein aggregations and make it more hydrophilic. So I think there are, and again, it's the technology that helps you overcome that to eventually have a food which you expect and has a acceptable taste. Now, I said that environmental footprint is important, so we also measure that for this product. So you can see here on the outer circle is basically from whole milk, and you have very different aspects of the environmental impact. It's not only CO2, it's also water, it's soil, etc. And if you take the hybrid, as I just showed you before, the dairy with soy, you actually reduce all of these environmental factors to a smaller level. So I think that is for me what is quite interesting, and you have the numbers here. They are quite significant. That you can halve almost the impact on the greenhouse gas emission, on the fresh water consumption, etc. So it's actually a product which I wanted to show as an example because we tick the boxes on the environmental side, on the nutrition side, and I think it's also because it's a powder and it has this hybrid, makes it very affordable. So this is for consumers which are really a bit less affluent, a very good option. So they get the taste from dairy that they are used to, they get good nutrient quality, we can enrich them with micronutrients as well, fortify with micronutrients, and it is at a very affordable cost. The fact that it's a powder, also we don't need to have cold chains which are not existing in many parts of the world, and eventually we can get also a larger penetration and scale and reach more remote areas. So my last slide is really just showing how important it is to bring all these disciplines together. So all of what I showed you is only possible by working hand in glove across all these expertises. So really from the agricultural sciences to the analytical sciences as well, to nutritional sciences, food sciences. And we have culinary expertise as well, because our chefs, they help us as well to see how do our prototypes behave. So very important with us as well. And also the packaging sciences, because that also has an impact on the environment. And so we make that a complete thing. So in summary, I think what is important to take away is that tailored micronutrient fortification to specific populations or wide scale is actually it's a very effective and it's a cost-effective measure, and it helps to close gaps or reduce the risk of deficiencies. And food technology, I think, as I hopefully have shown, is really a key enabler to deliver on products that meet the sensory experiences, that deliver a bioavailable compound, and that also address the challenges, the bioavailability. And then on the plant-based side, I think we have an opportunity to help a bit with the shift, and we see that this can address nutrition, it can address affordability, it can address environmental challenges. So with that, I thank you very much.